Hey guys, Wages World here, August 16th, 2020, coming at you with a video. Haven't did one this weekend, guys. I was trying to take the weekend off, but I guess the sun doesn't want me to. So, yeah, you want to see what I got to show you, or I would have just waited till tomorrow. But anyway, Sweet Butter here says, thanks for the great info on the Schumann. Says she's had a couple of headaches past couple days. And remember, this was back on my last video, so this was on the 13th and 14th. There was a spike there on the 13th and a smaller one on the 14th. And this is even back to when she was having those headaches right here. 12 to 13, 12 to the 13th, two significant spikes, guys. So that most definitely could have been it, Sweet Butter. But I would say this, guys. The Schumann touches everything. Frequency touches everything. But it isn't the only thing that can cause us to feel bad. Okay? We have our human bodies that are susceptible to a lot of different things. So we need to look at this and put this into our equation to get to the answer, but it cannot be the only thing we look at. We have to get all the advice we can, all the research that we can, or talk to your doctor, talk to your family, whatever. If you're feeling bad, don't just look at this and say, oh, yep, that's what's causing it, and keep moving. You have to look at this and say, man, maybe that is what's causing it. Let me go ask somebody if there's anything else going on that could be possibly making me feel the way that I'm feeling. And then you take it all into consideration. All right? That's what I'm trying to say. And I get a lot of questions, why do I talk about this every video? Well, let me tell you why. Frequency touches everything. I would challenge anybody to research any subject that they want. Well, I don't know, maybe like, Sweet Butter was her name, right? Research, does frequency affect the cow's output of milk or whatever when they're trying to make butter, before they turn butter with that milk? I guarantee you somewhere along the line you're going to find that somebody did some research somewhere with frequency on that. So, I'm talking and you could just, whatever subject, I don't even care. It don't have to be nothing to do at all with what we're talking about here. But it will definitely most likely be there, more times than not. So great comment, and I hope your headaches are getting better. This is Barika Latina, and she says, can comets make turns like that? Says it seems strange to her. She's just asking, right? Great question, Barika. Yes, they can make turns like that, and let me explain. She's talking about the comet that we thought could have been a UFO at first on Lasco C2, and as I did some more research and more days passed, I went and I found it on Stereo A, a totally different satellite. So we got a totally different perspective. Instead of looking at it from one angle, we got to look at it from the side angle. And looking at it on that angle, we seen that it formed a tail as it got closer to the sun. So that's how we knew that, or at least for me, that's how I knew that it was, for me, it's a comet. So that's how I knew. But she's talking about the turn it was making, like it was a sun diver. Now, there's sun grazers too, guys. They'll fly by the sun. They won't impact the sun, but the solar wind sometimes will disintegrate those objects too. They don't have to hit the surface to get destroyed. So that's kind of what I'm saying there. But as far as the turn goes, to answer your question here, what you're looking at when I show you those kinds of images, it's a time lapse. It's not a real-time movie, okay? So I'm showing you a time lapse of 6 to 7 days sometimes, especially on that one I showed you with the comet. Okay? So it took it 6 to 7 days to make that turn. It wasn't like it went out to one specific spot and just made a direct, bam, hard turn, like immediately. Even though it looks like a real hard, sharp turn, it is, but it's taking it days to accomplish that. So that's kind of what I want to point out there. I really think that's, for me, yes, I most definitely used to think the same thing. That's what it looks like. And I'm glad you made this comment, because I will clarify from now on so people understand a little bit better. So thanks. All right, this is a good comment here to get us back to where I want to talk about anyway. It says, how many sunspots this year? Well, David, this is David Williams. We've had 24. Okay, and that's only facing us. Guys, we got to keep in mind, for it to be a sunspot, it has to be Earth facing, and we have to be able to see it with our equipment, our technology. And it has to show the right characteristics for a certain amount of time before it even gets a designated number. What that means is there isn't anything that's going on in the backside of the sun. They don't even take in consideration on the sunspot number. All right, so we could have one on our side and there could be 4 on the other. We just don't know. So that's kind of what they've done here. And it, you know, and I'm not saying that their point of recording here is wrong. I'm just saying that there's sometimes it could be askew a little bit when you're trying to do, you know, get the proper activity level of the sun, because it could be active on the backside and not on the front. I mean, how many times do we see any of that stuff, right? We get a view from the side sometimes from stereo A, and we can kind of see that there's action that happens, but they don't see it on the front. So, just to put it in perspective here, last year we had 77% of the days with no sunspots facing us. Okay, that was a space age record. In other words, with modern day technology and the way we record stuff now, that was a record. Okay, now this year so far, if it was to end today, we would be at 68%, which is an 11% decrease. Okay, so that would be an 11% increase in activity, basically, is what that means. If we go back to the last sun cycle and we look at this is why I'm talking about, I think we're ramping up faster than what we typically do. Go back 11 years from last year and you get this. You get 73% at solar minimum. All right. The next year, there was only a 2% difference. So if it was to end today, you know, if that number was to end today, we would be 9% more. And what I mean by that is the activity would be at a 9% increase than what the difference was in our last solar cycle. I hope you guys understand that. So when I'm saying that, you know, the action's increasing quicker than what it typically does, I'm not just saying that by just looking at a couple of observations and just moving on. This right here is telling me that yes, right now we are ramping up quicker. Now that number could, I have to emphasize that this 68 could get bigger if we go through a dead spot where we don't see any sunspots at all, right, for another length of time. So that could get higher. We don't know yet, but as of right now, it looks as though we are ramping up quicker than what we usually do. So, and just to give you guys some sort of a visual here, that's what the sun looks like in solar minimum. That's what it looks like in solar maximum. Okay, so that's the difference we're talking about. So when we're talking about this, we have to also, you know, like I said, take in consideration that this is normal. This is a normal cycle, guys. This happens every 11 years. It ramps up, ramps down, ramps up, stays there for a minute, ramps down. All that kind of stuff. It's all normal, okay? But what's not staying normal right now is the quickness of us coming closer to more active conditions between year to year. And, you know, for me, that's what I'm seeing. But, you know, if that could change, though. I'm just showing it to you guys right now, and as of right now, we are ramping up quicker than what we usually do. So, all right, guys, I got you over here at spaceweather.com. Well, not spaceweather.com, sorry. Got you over at Space Weather Prediction Center. Look at this, guys. That's the solar X-ray flux. We had a C2 class level flare yesterday. I was going to bring it to you, and again, like I said, I was trying to take the weekend off. But then we get, you know, we get a smaller flare, and then we get this. Now, I want to point something out, okay? You see this right here? That is a solar flare. You see how it ramped up and ramped down really, really quick, right? This one's similar, the one in the middle. All right, now look at the third one there, what it did. Up, and then it's still falling off, right? Why? Well, because that's more of a CME than it is a solar flare. That's what you're seeing there. The X-rays increase a lot of the time with the CME. Also, they just don't. Basically, there's a solar flare there too, but it isn't the the main show. It ain't the star of the show, at least in that instance. Now over here, it's the star of the show because there is no CME there. Remember, a CME, that's actually plasma leaving the sun. Okay, the solar flare is X-rays. So that's why it gets here in 8 minutes. You know, CME is going to take it 2, 3, 4, 5 days sometimes. So, you know, obviously you guys know that we've had both here, and I'm going to show them to you here in a minute. But this also needs talked about because we are not active at all geomagnetically. Okay, when we got that C class 2 flare, it messed up radio propagation. There was a couple brownouts over in Asia on that side of the planet. We were on the dark side of the planet when that flare hit. Okay, but that did hit, and it was actually kind of hard to see on SDO and all that. You want to know why? Because of the stupid eclipse season. The Earth went in between the satellite and the sun at the exact time that that sucker fired off at us. So we didn't get to see it on SDO. The eclipse blocked us from seeing it. But you know, do I think that's kind of strange and fishy? I'm not sure if it's fishy, but I do think it's very strange. You know, we know it's predictable when these solar eclipses are going to happen. Not solar eclipses, but the eclipse of SDO, the satellite we look at. We know exactly when those are going to happen down to the second. We can't do that with a solar flare, guys. Okay, so I don't think that was intentionally done. Okay, that's just my opinion. It would be so many things would have to be wow, but just saying. Plus, it was a C2 flare. Okay, if it was an X flare and that happened, then I might be having a different conversation. But to cover up a C2 flare was just, for me, it's just not that, wouldn't be that big of a deal to do something like that. In other words, they probably wouldn't even bother with doing that, is what I'm trying to say. But anyway, anything's possible though. Here's the sun right now. We're going to take a look at that here in a few minutes on a different tool here. But you can see here, and when I'm talking about the eclipse thing, you see this? That's when those satellites are getting eclipsed. Line of sight's busted, so they cannot relay data. Now, I'm not talking about SDO with this particular ACE data here. This isn't what I'm speaking of, but it's essentially the same thing. So what we got here, you know, there's really not a whole lot going on at Earth right now. Okay? Things are out happening in space that we're going to have to pay attention to in the next couple days. So, let's go over here and look at this real quick. They changed that already. Wow. Huh. That is extremely strange. I just looked at this a minute ago, and man, this thing looked way different. Wow. Okay, hold on a minute. Yeah, guys, I don't know what's going on there with this particular Enlil graph right now, because it was showing something totally different a minute ago. I reset it. It looked different than what I just showed you guys, and now it's looking like this. So I don't know what's going on with that. So we're going to skip over this tool right now until I can figure that out. Okay, guys, this flare is going to, not flare, this is a CME. It looks to be a pretty big one, guys, and it's going to hit us right. I mean, we're going to take a direct hit from it. It looks like it might be going just a little bit to what we would consider our west, if you want to look at the sun from our perspective. To the left is what I would say to that, but it does look like we're going to take a dead hit from this sucker. Okay, this is again, man, yeah, there's the top down view. Earth's the yellow ball right there, guys. Sun's in the middle. This is the side view. Why do we look at all three? Because this is a two-dimensional model and we live in a three-dimensional world. So we see it here hitting us on the top down, we see it hitting us here on the side view, and then you'll see the disruption, wham, right on us. Okay, yeah, and this one here, guys, just judging by what I usually see, and I'll take you guys over to Lasco C2 here in a second. This looks like it's going to be a pretty powerful one, guys. I don't know, you know, like I said, as far as the strength, I can't really say, but this does look to be pretty significant. Okay, guys, this is Lasco C2. It's one I always show you guys, and this is on the 13th, and if you noticed, there was a little bit of action going on right there. Well, we had some flares and stuff going on that I showed you guys, right? And it would make sense that we can't see a whole lot because it would have been right in front of this occulter. Remember, that's just a black disc that blocks out the main light of the sun so we could even get a capture. Okay, so that's what that's for, and anything that happens behind that, we can't see it, and that's why it's more significant to us when this does happen, because that means it is coming right at us. When we don't, whatever we don't see that's moving this direction behind that will hit Earth. That's what we're kind of saying. So that's the 13th. That was the 14th. I'm sorry. This is the 15th. Now I want to show you guys something. See that one right there? That ain't the one I just showed you. That happened yesterday. Okay? And that was on the CME tracker. And then when I went and looked, it updated really quick for this one. Okay? So this is the one that just happened. I showed you is going to hit Earth right here. Okay? This is a significant one, guys. Okay? I'm not going to say that it looks really, really I don't like saying it. It looks powerful. And for a couple reasons. I'll see. We'll go over to SDO and see if we can't see it over there too. But the reason I say it looks powerful is it shot out pretty fast, like anyway. And then you've seen it come out on both sides of the occulter. Okay. Now, I do think that, you know, this was the initial blast. This over here that happens is almost a secondary CME. Okay, you know, I've talked about that before. A lot of times when we get a big CME, almost 180 degrees, if you drew a straight line through the sun, it wouldn't be in the exact position, but it would be close to that. Sometimes we'll get another CME, like on the other side. Like it's some sort of a reaction the sun does when it does big stuff like this. But you can also see there at the end of this time lapse, you'll see another little small ejection like that right here. Right there. See that little jet that shoots out? So stuff is going on, and it's going on our side now. And this is exactly what I've been talking about for a week. All this activity was going to rotate in towards us. And this is what we were talking about could happen, and it's happening. So what does that mean? It doesn't mean we freak out at all, okay? I don't know how powerful this thing is. Like I said, it's my opinion that this looks like it's a pretty strong one. But we won't know until they start hitting our detectors. And we got days to look at this. And, you know, I will say this. I don't think this is like Carrington event type of stuff, okay? I don't want you guys thinking that. But this does look to be one of the stronger ones I've seen in a long time that's come in our direction. Okay? So this could cause some issues. I don't know. We'll have to wait and see. I'll keep you guys updated, but we'll definitely, you're going to see like increased auroras, that kind of stuff. Who knows? You know, it could mess up GPS stuff. It could, you know, just depends on when and where this thing hits us. We're definitely going to see a hit on our magnetosphere. If this thing hits us like this thing looks like it's going to, we're just going to have to wait and see. But it did shoot off there pretty quick, like it did. That is a wide area. Okay, guys, this is over at SDO, and I took this back to the 14th because I wanted you guys to see the other flare that happened. Do you see? Watch this. I'll show you. Right about there. You see that blackout? That's one of the eclipses. Okay, this thing the Earth goes between the satellite and the sun. There's seasonal eclipses of this. We know exactly when they're going to happen, down to the minute, right? It's something predictable. So we knew that was going to happen. What wasn't predictable was the timing of a solar flare. It happened at that exact time that we didn't get to actually see it come off the sun on this satellite. Now, it's probably visible on other satellites. I'm just not going to go there because it's not, I mean, it's already happened. So there's not really a whole lot to gain by going right this second and looking at it. We may take a look at it, you know, at a later date, trying to dig into it. But there's enough other stuff going on right here, guys, that's, in my opinion, a little bit more of importance right now. But there was some brownouts, guys, with that solar flare. Okay, the United States was on the dark side of the planet when that solar flare hit, so it didn't really affect us. Over in Asia, they had some radio brownouts and stuff, but that was about it. That was really about the worst effect that we seen from that flare earlier. So you're going to see this flare, or the initial flare, CME, whatever you want to, you know, probably both, that blew off right there. And then this section of the sun becomes a little bit more active as it gets closer to us, and it blows about right here. And that's what we're looking at right now as far as what's coming at us today. So, I mean, this is, you know, an active area of the sun. We knew it, and we knew we were supposed to be watching for it. And right about there, you see that? Boom. That sucker blew. So, yeah. Again, it doesn't get that much more dead on to facing us before stuff like that happens than that. Okay, guys, I got you still over here at SDO, but this is from ISWA, the ISWA site. We get a lot better definition on this particular site. It's more of high def captures, so I'm going to show it to you here because you can see it better. Let's just push play. It's the same kind of thing, guys. Okay, it might be a little slower, but we'll be able to see more. And it's about ready to happen. Again, guys, it does move. I got it going as fast as I could, so obviously you guys seen that, correct? But we can run it back and watch it a couple different times here. Okay, it's getting ready right about. Bam. See that? Okay. That most definitely was a punch. And, you know, that is what it is, guys. I mean, we can do this too real quick. So I'll just run it back and forth. Right there. Boom. We can stop it. And any time we want here, let's trying to get in as far as I can without losing the capture there. So you can see it come from right in the middle of that sunspot, man. I mean, it really did. Bam. And we already know, we know that's going to happen, you know, around that kind of stuff. Let's look over here on this side. I never did look because we may have a little bit of a secondary, you know, eruption. Yeah, there was a couple. They're not real. Well, the one was decent, but it's not coming at us. It would be over here. If you guys want to take a look at that, you can. But right now, we're going to concentrate on this one. Because it, bam. I mean, look at that. See how fast that explodes out of there? And we can't let our guard down. A lot of times when these things start doing this, they keep coming. Okay? Especially with flares. Usually there's at least some smaller secondary ones coming from the same spot. A lot of times. Not always. Okay, let me say that. I'm going to say that. Not always. But a lot of times they are, especially on the bigger ones. Let's drag this back. Again, looking at that same spot, we'll be able to see it pretty good on this one. This is the 304. Boom. Bam. Okay. Now, again, that was coming our direction. I mean, there's no way we're going to miss this one. We're going to get some action from this thing. So, yeah. This is the one that shows us all the cool filaments and stuff around the edges, around the limbs of the sun. It most definitely is interesting for sure. But a lot of times this 131, I don't show this a whole lot, but sometimes it shows things better. Let's take a look at it here on this one. Might be able to see it better. Yeah, see that? Boom. But I mean, yeah. Most definitely, this is something that ain't gonna go away anytime soon. I would imagine after I post my video here, there might be people already out there talking about this. I don't know yet. But look at that, man. Bam. Bam. I mean, look at that. Sorry. I know I'm kind of quiet on this end of it, but I just think it's cool, number one. Number two, it is something we need to pay attention to because it most definitely could affect some things as it gets here. I do think that if this hits us like it's going to, that aurora photographers are going to be going nuts. They're going to love it. So, guys, I am going to end it here. Hope you guys have a good week, good start to your week. I'll try to give you guys updates on this. So, anyway, God bless. Yahushua saves, and you can drink this Kool-Aid.